Look at this beast of a question. Some people look at this and start immediately freaking out. Don't. Look. Look. 1 plus cos x, 1 minus cos x. These are conjugates of each other. This is what we're talking about in the last podcast. So you're going to have to, of course, because this is 1 over, you're going to have to find a common denominator. Well, guess what? That common denominator is actually a conjugate of each other, and it will result in a Pythagorean identity. One of these guys down here. So what am I talking about? Let me show you. Watch. Make this into a common denominator. You have to multiply this by 1 minus cos x. 1 minus cos x. There's the whole theme of common denominators, right? This guy over here would have to be multiplied by 1 plus cos x. 1 plus cos x. Oh, how beautiful, how pretty. Now, remember something from FOIL? I'm just going to write this down right now, but I want to show you something from FOIL that I think you need to be reminded of. Okay, this is in fact a FOIL operation here. So FOIL, here we go. First, watch this. 1 times 1 will give you 1. This will give you plus cos x. But here's the beauty of multiplying by conjugates. Watch this. Minus cos x times 1 will give you minus cos x. And then finally, this will give you minus cos squared x. This is based on that difference of squares idea. But do you notice something? These guys will always cancel. That's the whole idea behind conjugates. The whole idea behind conjugates is get rid of the oi in FOIL. Do you remember that? Yes, we did this like crazy in Math 20. But I want to show you that this actually becomes 1 minus cos squared x, which is a difference of squares, and that's why we use conjugates. Okay, enough said with that. Let's go back. Now that we've got the background information, let's go back and do it all over again. Ready? Here we go. Okay, watch. Real super cool. This guy, you know, they're conjugates. So, of course, in terms of FOIL, you're going to not do the oi because they cancel out. So do the first, 1 times 1, okay? That's going to be 1 times 1. Oh boy, that's tough. 1. And the last, minus cos x times cos x to give you, there's that difference of squares. Wow. And look at this one. 1 times 1 minus cos x. Oh, 1 minus cos x. Add that to, same thing here, because that's exactly the same. Look, there's your common denominator. 1 minus cos squared x, right? Multiply this out. Oh, boy, that's tough. Now that you've got it as a common denominator, you can put them together as one wonderful, beautiful common denominator. So there it is. That's why we put them together, which means it's this guy here, 1 minus cos x, added to 1 plus cos x. Oh, how beautiful. Oh, this is turning out to be so incredibly sweet. Notice I haven't even touched the right-hand side yet. Let's deal just 100% with the left-hand side and see what we get. You're going to be in for a surprise. Ready? Look, minus cos x and positive cos x. Goodbye. They cancel, leaving you 1 plus 1. Oh, check this out. 1 plus 1, you know, is 2. This is 2 over 1 minus cos squared x. Do you remember a couple of minutes ago I was saying, hey, don't forget, the nice thing about conjugates is that they're going to lead to one of these Pythagorean identities. Look what you have here. I'm just going to move this whole thing down just a couple steps here. Look what you have here. Look what you have. This is amazing. You have that 1 minus cos squared x. That's this guy right here. How do you know? All you have to do is manipulate this a little bit. Look, take this cos squared x, right? Plus sine squared x equals to 1, right? Make it look like this guy. And all that you have to do to make it look like this guy is subtract cos squared x from both sides. Look, simple algebra. That cancels out, leaving you sine squared x equals to 1 minus cos squared x. Oh, that's so tough. Now, You know, and I know at this point then, is I can take this, right, which is right here, and replace it with sine squared x. Oh, how pretty. Oh, how pretty. So this means that this is 2 over sine squared x. Sweet. Because you know what's cool about this? This is like saying 2 times 1 over sine squared x. Guys, ladies and gentlemen, what is 1 over a sine? Oh, 1 over sine, isn't that cosecant? So isn't this cosecant squared x? That looks awfully familiar for some reason. That looks awfully familiar for some reason. Wait a second. Where have I seen this before? Could it be? Could it be? Could it be? Where? My goodness, there it is. You betcha. That was the right-hand side of our equation. Look at that. That equals to 2 cosecant squared x. You made the left side equal to the right side. You didn't even touch the right side. Guess what, baby? Put the square, shaded square down. You are done.